Okay, so now the tests that Hillman was showing are more like they're not really necessarily testing the implementation because there's not a lot of implementation going on here. So they're testing more how their the EMF framework, if the EMF framework is providing the correct references and providing the correct instantiations, is the framework following the rules that are specifying the model, etc. This is the kind of test that Hillman is proposing here. On your own assignment, you could test implementation details. If you have some implementation, you can test if your implementation is working correctly, or you just can test if the EMF framework is working correctly in your project, right? In this case, the test is called test matchup game reference, and again, it does that. It tests that there is a correct that the bowling factory is creating a matchup correctly, right? So this is what we're seeing here. We have a matchup being created by the bowling factory, right? So it creates an instance of create matchup, an instance of matchup actually of the class matchup. Bowling factory as well can create a game, right? So now we're using part of the interface of create matchup. We're using get games, and this is just to get a game that is in the matchup, and then we take that game's reference that's in matchup and we add a game to it. Okay, we add a game to the create matchup instance, right, to the matchup. So, and then we say, the question we're asking here is the matchup, right, that's in create game in the variable the same as the parent matchup, the create matchup? Okay, so basically we added a game to the matchup, and also in at the same time we created a reference to the matchup on the create game, and I think that reference is created by the model itself. Whenever we create a game from the bowling factory, it automatically creates a reference to the matchup. Okay, so we're testing in a way also that's bidirectionality or bidirectionality. Is it bidirectional? And I think that comes from here. Here, you see, it doesn't have the arrow. That means that the matchup contains a game, or has the matchup has a reference to the game, and the game has a reference to the matchup. Okay, and I think that's what we're testing here to see if that relationship is holding. Are these two objects the same, and are they pointing to the same place in memory? Right? Is it the same pointer? So it turns out to be that it is true. That means that our model is being implemented correctly by the EMF framework. Hopefully that made sense. Okay. Next one, testing reflection. Now, eObjects offer reflective access to their attributes using the methods eSet and eGet. This can be useful in modifying an entity in a generic way. So let's just explain what's going on here. eObject is more a generic EMF framework object, and we're assigning to it a player instance. After that, to this player instance, right? Create player. To this eObject, but it's also a player instance, we are setting its name, a player name, to Jonas. Right? Then we take here a player and we assign it to eObject. We're casting, eObject as a player because we actually created a player, right? That's what we gave it. The value that we have instantiated for eObject. So we cast it as player so it doesn't throw an error. Now we are gonna try to assert that the name of this e-object of this player, right, same thing, equals Jonah. And in a way we're testing that this call here, e-object eset, right, get player name, right, we're setting the player name to Jonas. So we are testing the the reflective axis, right, the eset power of EMF, and the test is is asserting it to true, so it's passing it. So the reflection properties of EMF are working properly for this this model, this bowling model. Okay, next test reflective information. And let me reading here information about the available E attributes and E references, as well as all additional concepts we have modeled before, can be accessed either through the E class or through E package. The following test checks whether a reference of league is a multiplicity greater than 1, is many represents whether at least one value is required for a valid instance. I really don't understand that much as what this means. I can explain what the code is doing. So we use a bowling factory to create a league instance, and we're trying to assert that this call is many returns a true. Okay, and that means that at least one value is required for a valid instance. So you need to have at least one or more values for the league class. I'm sorry, not for the league, but yeah, for the league. Yeah. All the references that it has. But if you trace this guy here, at least here, you are gonna find out that it's referring to the players. And if you trace this guy here, get league players, again it goes back and it refers to the players, right? These two are supposed to give you the same. Get 0, get all references, get 0. Well, it's giving you the players. Same thing here, and it's let's just show what matchup test reflective information. Okay. So again here, test reflective information, and if you notice here, these two references are the same, right? This reference here and all the data from it comes from this log on top, and same down here, the reference name is the same, the data is the same. All this is the same data. So we're accessing class property from different in different ways using the EMF framework. Using that package A instance, get league players is the same as saying create league E class, get all references, get 0, and that's the 0, the reference at index 0 from this list that comes out of get E all references. Okay. Okay, moving on. Now, sometimes the models have rules in terms of how many total instances could and can be created. And matchup can only have, right, consists of 2 games, and this was defined in here, right? A matchup can only have point to 2 games, so have 2 instances of the game class. That's the maximum it can have, and that's what we're testing here. Where on purpose we are only giving it one game, right? We have a matchup, and then we just add 1 game. And it's, well, the rule is that it needs to have 2 games, exactly 2 games. It cannot have less than 2. It needs to be exactly 2 games. So we on purpose give it 1 game, and it should throw an error, right? So diagnostic error should, the string from diagnostic error should equal the string from validate get severity. In other words, it should be throwing an error. Now when we trace what validated string says, that's in here, test validation, okay? The diagnostic error, okay? Source, and it goes right here, diagnosis of bowling of that implementation, right? For the matchup class. Okay, the feature gains of bowling matchup with 1 value must have at least 2 values. Okay, it only has 1 value, must have at least 2 values. So we're validating that the rules, that this rule that we gave it, right, for this reference, the upper limit is 2. Actually, not upper, but actual, the only number of gains that a matchup can have is 2. So okay, moving on, we have the test copy. So I've been reading here. EMF provides many utility classes. Very important one is eCore util. It's worthwhile browsing through the available methods of eCore utility. We'll use a copy method to create a copy of an ENA object. So we're just testing that the utilities from an EMF, right, from eCore utility, that they work, right? Now, this is like a cloning method, right? We create a player, we give it a name Jonah, and we have a copy, right, of that player, and it's actually a copy of the data, but this copy should create a new pointer, a new space in memory. So this is why we assert that they're not the same, right? So they're not the same in terms of where are they pointing in memory. They're not the same object in memory, but we can test that their data, right, the get name, the name is the same. So they have the same data, but they have different pointers, different locations in memory. And I did information, a logger, a trace call to create player to just convert that object to string, to string description. Same thing of the copy. And if you notice here, we have 2 different instances, right? 2 different places in memory, right? But the objects have the same data, and I think that's a great feature of EMF, the eCore util, to be able to copy a player, you know, and copy its data, but not, you know, but have a separate instance of it. You'll find that to be really powerful when you code. And I'm gonna run this again just to make sure that everything is okay, that I fix my problems that I had before, and I say run as the unit test, and boom, passed all my tests. And hopefully it was some way, somehow useful, you know, the information I gave in this video.